Hello and welcome to the tutorial on topic 4. This is on interest rate expectations through a regression analysis. So we're just going to take a peek here at how this is actually laid out. Here we are given the maturities and the observed spot rates. And then the dependent variable here is the observed discount factor, which is just right here. It's the observed discount factor equals 1 over the observed spot rate to the nth power. So that's this formula, 1 over 1 plus the observed spot rate to the nth power. So that you just carry down all the way. And then here is just the period n, and then n to the second power and n to the third power, and that's useful in this equation, which is our kind of regression formula. This is sort of spline smoothing and regression light. It's not fully in depth. So what we do is we run a regression. So to do that, we go to data and we go to data analysis. And remember, if you don't have this, you can go to Excel options, add-ins go, and then make sure you have analysis tool back. So we'll do data analysis and click regression, press OK. So for the Y range, we want the observed discount factors. Okay, that's what we just converted from the observed spot rates. Alright, and then the X range we want is the, there you go, it's the independent variables. Alright, so okay, and we can click labels if we want, and we're going to put it as a new worksheet, and you want to click line fit plots and press OK, and it should put this all in a new worksheet for you, and I've just converted it all and made it all look prettier in this version of it, but you know, your version should have the same numbers. It just might be a little formatted a little differently. So this is a great link here of kind of what does all this mean. It's from UC Davis, and it goes through what an actual regression in Excel means through the ANOVA table and the coefficient table and everything, and you can take a peek at that. So the thing we want to look at here is R squared, and this has been kind of artificially made so that these numbers are really perfect. The R squared usually says how well does your regression line fit the actual numbers, and here it's a value between 0 and 1, so like 0.01 would be a weak regression or a weak fit, and 0.9999999 is a strong fit. Okay, so this is now just kind of an intermediate step. We have all these values here. It's important to look at the coefficients here. And these coefficients are actually the coefficients for this formula. And we're going to get to that right here. This part in red is building that formula. So the predicted Y equals the estimated discount factor. So all that is C29, and that is your residuals table here, C29. So that's predicted Y right there, 95.29. And then C30, C31, C32. And then the estimated spot rate, this is 1 over the actual, the predicted Y to the 1 over the year power, so 1 over 1, which is 1 in this case, and then that all minus 1, the whole thing minus 1. And that gives you the estimated spot rate for that period. And then the intercepts just come from the coefficients here, so the intercept, which is in your formula A plus all of this, A is your intercept, right here, A is your intercept, so it's always going to be 1.01, because if you're looking at a line, you know, that runs through a point, it's always the regression line always has the same intercept. Okay, the estimated coefficient on n here, so that's b. That's going to always be the same, and then the estimated coefficient on n squared, which is going to be c, and then the estimated coefficient on n cubed, and that's going to be d in our formula. And you can see these are just taken right from here. Alright, so now we see n cubed. Alright, so now this right here, this row or column n actually builds the formula and gives you the estimated discount rate for the period. So that is just because our formula here, the regression formula, d to the d as a function of n gives you the estimated discount rate for that period. All this formula does here is build the answer. So J4 is our intercept plus K4 to E times E4, K4 being our coefficient, and E4 being our n. Okay, and L4 being our coefficient, F4 being the n squared, G4 being the coefficient, and M4 being n cubed. So that gives you the estimated discount rates. So that is pretty much all we're doing here. We're given just this tiny little amount of data. We have to go through a lot of steps to convert it into something usable. You know, this part here is what we use to run the regression with, and then this part here is what we use to run or to build our regression equation with. And then this last column n gives us our actual results. So you know, there's so much theory, and it's way too complex to go over all the regression details with you, but hopefully that will be cleared up in class.